This video will look at counting, figuring out how many ways an event can occur. I'll use the multiplication principle and introduce you to factorials. The multiplication principle is if there are m ways to perform task 1 and n ways to perform task 2, then there are m times n ways to perform tasks 1 and 2. Here's a great example. If a car's color combination has 5 exterior color selections and 3 interior color selections, how many color combinations are there? And many years ago, I bought a Kia Spectra, and when I purchased that car, it was a great price, so I was able to get into a brand new car. And I had the option of certain numbers of exterior colors and then just 2 interior colors. I think they were gray or tan. So I had a few options on how I wanted my car to be. In this problem, we can see that there's actually 5 exterior colors and 3 interior colors. So one way to do this problem is to visualize it and envision that there's this car, kind of this starting point. And I can pick my exterior colors, and I have 5 of them that I can pick from. And then once I've picked my exterior color, I have to pick an interior color. So color 1 on the outside would then have 3 interior colors I could pick from. And same for color 2 on the outside. We can see that there's a lot of branches altogether. By the time we're done, we could count how many little tiny branch options we have all together. So from the beginning, I was picking a car, and if I picked color 1, then on the outside, then I had 3 colors to pick from for the inside. And we could count all of these up at the very end. That process is manageable in this problem, but imagine something that had a lot of options. Then it becomes unmanageable. So we need the multiplication principle. And the multiplication principle allows us to recognize that the exterior color, that there were 5 to pick from, and for the interior color, there were 3 to pick from. So I can multiply these together and get 15 color combinations. Let's take a look at one more example. It says, suppose that a license plate consists of a non-zero digit followed by 3 different letters and then 3 non-zero digits. How many such license plates are there? Well, it's important to notice some of the language. One of the language says non-zero. So we have to think about single digit numbers like 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now there are 9 non-digit numbers. So my license plate starts with one of 9 numbers. Then it's followed by 3 different letters. That means I can't repeat my letters. Well, there's many letters in the alphabet. For my first letter, there's 26 letters I could pick from. But once I've picked that first letter, now there's only 25 to pick from. And when I pick the second letter, now there's only 24 letters to select for that third letter. It finishes with 3 more non-digit numbers. Now, it doesn't mention that these 3 non-digit numbers couldn't have occurred already. So we could actually have still 9 digits to pick from. It doesn't say anything about the numbers not being able to be repeated or having to be different. So I need to multiply all these values together. I have a calculator with me, so I could take 9 to the 4th power, since there's 4 9s, multiply it with 26, 25, and 24. And this gives me a very large number, 102,351,600. So 102,351,600 different license plates that can be generated. Now I'm going to move on down to factorials. Factorial is a notation that also is an extension of the multiplication principle. So a factorial, if n is a counting number, now some will say integer, but both work. If n is a counting number, then n factorial is the product of that number you start with, n, times one number smaller, times the next number, until you get down to 3, 2, 1. And also by definition, this is needed usually on a different day, but 0 factorial is equal to 1. That's just a definition. There's no real reason behind it other than that's what it is. Okay, so what does a basic calculation with a factorial look like? Well, let's say I had said n is 5. So I've got 5 factorial. I start by writing 5, and then I count down. 4, 3, 2, 1. You want to multiply all of those together. When you multiply them together, you get 120. So 5 factorial is equal to 120. What that means is if I had, say, 5 items, and I wanted to arrange them all in a line, there's 120 different ways I could arrange those in a line. Please notice that there are factorial buttons on calculators, both personal handheld calculators, phones that have scientific calculators, and also websites. So please don't actually type 5 times 4 times 3 times 2 times 1 into your calculator. Instead, type in 5, look for the exclamation mark, and notice that the answer then becomes 120 on your calculator. Okay, now to apply this to a problem. There are 7 children to arrange in a line. How many line arrangements are there? Okay, I have to make an assumption. One assumption is that I'm going to use all 7 children, and that I'm going to be in a straight line, not circular. That becomes a very different problem if it's circular. So what I'm doing is I'm looking at a 7 factorial. Its meaning is here in the middle. Now, I actually don't write down this extended meaning when I work these out. Instead, I go straight to my technology, 7 factorial. I find out that there are 5,040 ways to line up 7 children.